Okay, in this problem we have two dice that are rolled. First one says find the odds of rolling a sum, and the odds of rolling a sum is your desired outcome. You could also call it the favorable outcome, divided by the total number of outcomes. Okay, and then find the odds in favor of rolling a sum. That's a little different. On that, you have favorable outcomes. That's the same as desired outcomes. And then you have unfavorable outcomes. Okay, so to find the unfavorable outcomes, you would just subtract the total number of outcomes, to subtract the unfavorable outcomes or favorable outcomes from that to get this. And I'll show you in a few examples. Okay, so on the first one, let's say we want to find a sum equal to 10. Okay, so for the first one, which is just the probability, straight up probability of rolling a sum that's equal to 10. Okay, so you need to figure out how many of desired outcomes divided by total number of outcomes. Okay, so the total when you're dividing, or when you have two die and you're rolling, the total number of outcomes that you can have is 36. That's because there's 6 numbers on each die, and 6 times 6 equals 36. That's your total outcome. It's going to be the total outcome throughout this entire problem. Okay, so 36 goes on bottom. Our question is what goes on top? What goes in the numerator? Okay, desired outcomes. Okay, so how do we roll a 10? So let's assume our first die lands a 1. Is there anything that could go with a 1 to give 10? Well, the numbers only go to 6, so there's nothing. That you'd have to be a 9, and there isn't one. So that doesn't work. 2 would have to go with what? 8? That's not possible. 3 would have to go with 7. That's not possible. So all 3 of those are not possible. Okay. Now 4 could go with 6. That works. 6 could go with 4. That works. And 5 could go with 5. That works. So that gives you 3 outcomes out of 36, which reduces to 1 over 12. Okay. Now odds in favor of rolling a sum is almost the same. Call that probability of B, odds in favor. The numerator is going to say the same. The denominator is found by subtracting this, subtracting the total number of outcomes minus your favorable ones. Total number of outcomes is 36 minus your favorable ones, which is 3. So that gives 33. 3 over 33 gives you 1 over 11. 1 to 11. So this says if you roll the die 12 times, you can expect one of them to give you a sum equal to 10 and 11 that won't give you a sum equal to 10. Okay, let's try another one. Let's say that we want a sum greater than 5. Okay, again, our total number of outcomes is 36. We need to figure out how many outcomes give us a sum greater than 5. And there's 2 different ways to go about this. We could find the total number or the total possibilities that are less than 5 and subtract, or you could just write out every sum that gives you greater than 5. I'm going to do the first one. So 1, 1, that's less than 5. 1, 2, 1, 3, 1, 4, that's less than or equal to 5. Okay, so all these are less than or equal to 5. They're not greater than 5. Okay, 2, 1, 2, 2, 2, 3. All those are less than or equal to 5. 3, 1, and 3, 2, and 4, 1. Okay, so these are your possibilities that are less than or equal to 5, and there's how many? 10? Okay, so how many possibilities are, let me write this down. Greater than 5. Well, if we know there's 36 and there's 10 of them that don't work, 36 minus 10 equals 26. So there's 26 favorable outcomes. Okay, so P of A is going to be equal to 26 favorable outcomes or desired outcomes divided by the total number of outcomes, which is 36. So you divide that by 2, you get 13 over 18. Now the odds in favor of this, the 26 is going to be the same, but the bottom is going to be 36 minus 26, just like we did last time. 36 minus 26 gives you 10. So 26 over 10, which reduces to 13 over 5, or you can write it as 13 to 5. So out of 18 total rolls, you can expect 13 of them to give a sum greater than 5. You can expect 5 of them to not give a sum greater than 5. Okay? let's try one more. Let's say the odds that the sum is even. Okay, so sum is even. So if my first die is a 1, my second die has to be a 1, a 3, or a 5. All three of those add up to get an even number. If its first die is a 2, the second one has to be a 2, a 4, or a 6. If the first die is a 3, then the second one needs to be 1, 3, or 5. If it's a 4, it needs to be 2, 4, or 6. If it's a 5, it needs to be 1, 3, or 5. I hope you see the pattern. If it's a 6, it's got to be 2, 4, or 6 as the second die. Okay, so there's your possibility of sums that's even. You have 3 times 6, which is 18 possibilities. So probability of rolling a sum that's even is going to be 18 out of total, which is 36, or 1 over 2. That answer should make sense. Since half of the numbers on a die are even and half are odd, then the probability of sum being even should also be 1/2, or 50%. Now, what are the odds in favor? Well, 18 stays the same, but the bottom becomes 36 minus 18, which is 18 over 18, which reduces to 1 over 1, or 1 to 1. That means if you roll 2 times, you can expect one of them to give you a sum that's even and one of them to give you the sum that's odd. Will that happen every time? No. But if I roll 1,000 times, I can expect that somewhere around 500 times the sum will be even, and somewhere around 500 times the sum will be odd. It's about even. It's not going to be perfect, but it does give you the probability.